Hi, today we're going to take a look at using graphing calculator technology to help us achieve our goal, to write an equation that models the data. This is really getting at the heart of linear regression, our Unit 2 topic. So here's just an example of a scatter plot that we may have come up with over the last couple of weeks. We can recognize here that we have a positive trend as our data is increasing as we move across from left to right. So the higher the x values, the higher the y values. So our goal again is to write an equation that models this data. So we're going to try to come up with a line, like our trend line or line of best fit, and then find the slope of that line and the y-intercept of that line to be able to write our equation. So here's how we do that using a graphing technology called Desmos. So you're going to want to go to www.desmos.com, and I would recommend bookmarking this page. When you get there, you'll see this message right in the middle of the screen, and you can just click Graphing Calculator, and it will take you to the Graphing Calculator. Once you're there, you'll see on the left-hand side of your screen a bunch of empty blanks where you can enter in regular math problems or you can type in equations for graphing purposes. And then in the upper left-hand corner, you'll see a plus sign. That's the Add Item button. So you click on that to insert an item, and you'll get a drop-down menu. We want to choose Table, because what we're going to do is we're going to enter our data for the scatter plot into a table form so the graphing calculator can take the exact data. So you click Table, then you start typing in your entries, putting your x values on the left and your y values on the right. Make sure that your entries match and that you have an equal number of x's and y's, or it won't work nicely. After you've graphed, you might see your data in the table, but if your data is numbers in the hundreds or even thousands, you're not going to see it from your standard Windows screen. So there's a little magnifying glass with a plus sign in it on the left-hand side of your screen. It's actually going to be more in line over here with your table, kind of at the bottom of your table. But you're going to find this little magnifying glass and you're going to want to click on that. And what it's going to do is it's going to change your graphing screen so that your data is centered on your screen. Now, you'll have to keep in mind that your X and Y axes will look very different when you do this, as it zooms in on just a picture of the data and not keeping the origin at the center of your screen. But when you do this, you can describe the correlation of the data. For example, in this data, I can see that my correlation is negative. There's definitely a negative trend here. It's actually pretty strong too, by the looks of things. So a strong negative correlation. All right, so we're going to go ahead and take a look at an example. What I have here is some data from the 2019 World Series Game 5, where 8 different pitchers were used during the game. We were recording the number of strikes that pitcher threw compared to the total number of pitches that pitcher threw. So obviously the ones that weren't strikes were balls. And we are going to use the technology to make a scatter plot to describe the correlation and to estimate an R value, which is our correlation coefficient from last week. So first thing I need to do is go to Desmos.com. I'm going to kind of pull this off to the side. I hit Graphing Calculator. And here's where we have the graphing screen on the right and the entry screen on the left. If I wanted to just do basic math, I could type in things like 4 plus 5 equals 9. 5 times 7 equals 35. 3 parentheses 4 minus 6 parentheses equals -6. So I can do stuff like that. If I want to get rid of that, I just hit the X, or I can go to, I believe it's delete all. There we go. It clears everything. But I want to enter my data into a table. So I have to hit Add Item, choose Table, and now it'll build a table in my first calculator window. So I'm just going to go in order. So my X's are on the left, my Y's are on the right. I type in 71 strikes, 110 pitches, 15 strikes for 16 pitches, 11 strikes for 13 pitches. I'm using the Tab key to just move. It just moves across the row and then down to the beginning of the next row. So 48 strikes, I hit a tab, 78 pitches. When I hit tab again, it brings me down to the beginning of the next row. So it actually makes it quite easy and quick to type in my data. And that last pitcher did really well. Only had to throw 2 pitches, got 2 strikes, probably only faced 1 batter to get 1 out. Now, when I do that, I can see that my data is kind of all over the place. I could see a dot here, and it looked like there's some other dots up there because my origin's centered. If I want to see where my data is and center my actual data, I hit the magnifying glass here. Notice how it rezooms everything. So now I can see a little bit better, and I actually see the origin here. My y-axis is the number of pitches, my x-axis is the number of strikes, and I can see a definite positive trend. Okay, that the more strikes are thrown, the more pitches were thrown. And I guess that makes sense because you have to throw more pitches to get more strikes. All right, so that's the first part. Let's go back and take a look at our questions. What were we supposed to do with this? Make a scatter plot, which we did. Describe the correlation. It is a strong positive correlation based on what I'm saying. And estimate an R value. Well, if it's a strong positive correlation, I would say the R value would probably be around, remember it has to be, between 0 and 1, so 0 point something. And the stronger the correlation, the closer to 1 it is. So I'm going to say about 0.95 because I thought it looked pretty good. I'm going to go back to it for a second, full screen. I think it looks like things line up pretty nicely. There's a little up and down at the beginning, but in the grand scheme of things, when I draw my line of fit here, they're not that far away from the line. It's a pretty good fit. All right, so then how do we find the actual R value? How do we get the line of fit to appear on our data? And how do we get the slope and the y-intercept of the line? That's the next step. So here's our third step. Find the exact line of best fit. Okay, find the exact line of best fit. So in Desmos, we are going to type this exact code. This is like think of it as computer programming code that you have to type this in to get what you want out of it. So this equation, it can be kind of confusing, but here's what you're looking at. It models something we know. We know y equals mx plus b very well. But it's specific, not just x and y, it's x1 and y1. It's a very specific set of data on the table that it wants us to use. Because if I go back here for a second, notice in my table, it's not just x and y, it's x1 and y1. So when I type my equation, it's going to pull from that, y equals mx plus b. So I can kind of start with that, but I want to make it specific. y1 means it's from the table, and x1 is from the table. And you'd be like, whoa, where'd my data go? My table's gone. And that's because I have an equals there. And my data doesn't fit an exact line. It's not actually equal. So what I have to do is I have to delete the equal sign, and I have to do the squiggle sign, which is next to the number 1 key on your keyboard. But it's also when you have to hold down the shift button and that little squiggle key, or tilde, I believe it's called, to get that symbol to appear. So y1 squiggle mx1 plus b. Or you can do how I did it. I just said y equals mx plus b, make it x1, y1. And I didn't do anything special. I just typed the number 1 after the variable, and your Desmos calculator knows to make it a subscript. It just automatically does it. It's so neat. And then don't forget to change the equal sign to the squiggle. That's super important because we're not coming up with a line that fits all of the data perfectly. It's an estimate of a best fit line. Okay, it's the best that we can get. So here's how we read. We get a lot of different things here. We get some statistics. It says residuals. It says parameters. So I want to go back to my presentation here for just a second. So when you see this screen, after you type in y1 squiggle mx1 plus b, these statistics, there's an r to the second power and there's an r. The r value is the correlation coefficient. Remember last week on our ed puzzle, we had to estimate our own r values? Yeah, this is the actual r value for a set of data. Now, this data is not the same as the one that we were looking at. So that's why this one is not showing a very strong correlation. This is about 0.6 or close to it if we rounded to the nearest tenth. And that would show a, kind of a weak positive correlation, kind of really close to that weak correlation, strong correlation border of about 0.7. So there's a correlation there. It's definitely positive because it's a positive number, but it's not real strong. The stronger it is, the closer to 1.0 it is. Then down below, we have M and we have B. Where have we seen that before? That's right. M is the slope of the line and B is the y-intercept of the line. So what we would have to do is write an equation that says y equals, and we type all of these numbers in there as the slope. So mx plus b, again with all of those numbers. And I think I have it here. There it is. So these are the exact same numbers. The green is the m from the previous screen, and this blue number is b from the previous screen. So y equals mx plus b is our model. If you wanted to graph that in Desmos, you would just type this into Desmos, and it would show you what your line looked like. And actually, I think after you do the linear regression piece, with the squiggle equation, I think it already does it for you. All right, so I want to go back here, just take a look at it. Oh yeah, it did. So notice I have my line drawn. I can see that my points are pretty close. That's your trend line. That's your line of best fit. And that's the equation that we could use to make different predictions. So I'm going to go ahead and just type that in, y equals, and then I typed in my slope value, put an x after it, and then you can put plus negative 1.21142, or I never like the double sign, so I just use the minus sign instead. And you'll notice that now I have this red line that overlaps that line of best fit that I had before from here. I can just hide that. If I hide them both, I don't see any of it. Okay, there's my regression line. And there's my regression line that I graphed on my own using the Desmos graphing calculator. All right, so that is how you can use Desmos graphing calculator to perform linear regression for you.